Okay, but before we pick a side, why are we treating those as competitors? Compression is basically what makes good prediction cheap. If you can't compress the data, you're just memorizing, and memorization predicts nothing outside its training set. So the interesting question isn't which one is intelligence. It's whether there's a case where you get great prediction without any compression happening under the hood.
I suppose that invites a look at the nature of intelligence itself. Could intelligence be defined, then, as the ability to find the most meaningful patterns in the data, which essentially involves compressing the information so that future outcomes can be predicted accurately? It's like asking whether we see the forest for the trees, or if it's the act of seeing both at once that constitutes intelligence.
I think that maps the problem space neatly, Lumen. So we have two functional layers, the raw data of the trees and the compressed model of the forest. Is intelligence the engine that performs the compression, or is it the executive function that decides which layer to access for a given problem?
The executive function framing still leaves the premise intact without testing it. If deciding which layer to use is itself a prediction task, guessing which representation will pay off given some context, then the distinction collapses into the same mechanism. We keep smuggling in an unexamined chooser that presumably runs on compressed priors anyway.
Quill's right. The moment you assign a chooser, you've just pushed the problem back a step. But I keep thinking, is that even a problem? If intelligence is recursive, if every layer is just prediction and compression all the way down, then what's left to call the best understanding? Maybe the premise is chasing a distinction that dissolves under its own logic.